quadratic functions. So the quadratic function is called a parabola. A quadratic function is a degree of 2, which means that it's a polynomial function in which the highest degree of the exponent is 2 for it. The general equation for a quadratic function looks like that. Y equals ax squared plus bx plus c, in which a, b, and c are coefficients, and a cannot equal 0. All right? Now, a standard parabola is a U shape. It looks something like that. Okay? The turning point, there's one turning point, and that's right here. And at that point, that is called the vertex. Now, the vertex is going to be important to us because it's going to explain a number of different pieces or properties about this here. So in this case, this vertex will be 0, and let's just say it's C, whatever the coordinate is right there, wherever it passes the y-intercept.
Is it always going to be on the...
No, it's not always going to be on the axis. Okay, so we're going to look at what happens when we change A, B, and C today. But this is the basics of it. Now, a parabola has some unique properties to it. The first property that's unique to it is it's symmetrical. Symmetrical means it's exactly the same on both sides of what we're going to call the axis of symmetry. So in this case, our axis of symmetry is this line right here. Okay? This is what we call the axis of symmetry. The axis of symmetry is a line that divides the parabola into 2 equal parts. The book will ask you for the equation of the axis of symmetry. The equation of the axis of symmetry is going to be x equals whatever the value of the x value of the vertex is. In this case, x is equal to 0. So the axis of symmetry is a line that divides it into 2 equal parts, and you will be asked to write the equation of the axis of symmetry. And again, I said how important this vertex is it tells us what the axis of symmetry, which x value it goes through. Next, the vertex is also what we refer to as a minimum or maximum value. It's a minimum value if the parabola opens up, because all the y values then are greater than that value right there. Therefore, that's the minimum y value. This also helps us give an indication as to what the range will be. And the range for this the parabola in this case will be y such that y is greater than or equal to, in this case it's c. Now that changes, but it's all dependent on what the y value of that vertex is, where y is an element of all real numbers. So we're going to do a little bit more work on that as we get going. The domain for this graph. And again, some of us forget how to find out what the domain and range is. The domain for this graph is how far left does this graph go? Negative infinity. Right? And how far right does this graph go? Positive infinity. And includes everything in between that. So we can write it like that, or we can write it as x is an element of all real numbers. Okay? Either method works just fine. When I do my range, I always take the bottom value, which will be indicated in the vertex. And then the top value, which is, in this case, positive infinity. So that takes care of everything. All right, now, A. What is the significance of A on the graph? Well, here's what I'm going to do to talk about A. I'm going to look at y equals x squared, and I'll look at a table of values for y equals x squared. If x is minus 2, what does y equal? By putting it in the equation, what does y equal?
4.
What is it?
4.
4. If x is minus 1, what does y equal? 1. If x is 0, what does y equal? 0. If x is 1, what does y equal? 1 and 4. Notice it's symmetrical. Okay? So we go to here, to here. So there's y equals x squared. Okay? First thing I want to show you is what happens if a is less than 0? What happens if a is a negative number? So I have y equals x squared. If that's negative 2, and I put it into this equation here, what does y equal? Do we agree? What's negative 2 times negative 2? Positive 4 times negative 1 is? Negative 4. All right, I'm going to put negative 1 in there. What does it equal?
Negative 1.
Minus 1. 0? 1?
Negative
1. And 2? So what has happened to my graph? By changing the a value to a negative value, what did I do with my graph? It flipped. That's exactly right. It flipped and went down this way. So the very first thing that you want to know is if a is greater than 0, the quadratic function will open up. If a is less than 0, it opens down. Okay? Now looking at it, my vertex is right here. My vertex is 0 and 0. On the red graph, the y equals negative x squared. Is that a maximum or a minimum value now?
Maximum.
It's a maximum value because all the y values are lower than that value. Correct? Okay, good. What's the range for this graph?
Negative infinity to positive infinity.
No.
Negative infinity to negative infinity.
No.
Y is less than 0. But
Less than or
sounds like
equal to 0.
Alright.
Yeah, you're right. Okay, so go back to the way you guys say it. What's the lowest possible value? Negative infinity. Lowest, right? So down here, negative infinity, correct? What's the highest value?
0.
0. So it would be, to write the range for this one, I can do it the way Sophia said, or I could go negative infinity to 0, and it has to include 0 because it does come right up to 0. So to write it the other way, y such that y is less than or equal to 0 for that graph. So if it's a maximum value, then it's going to be, all my y values are going to be less than that value. So it becomes a maximum value. All right? Any questions so far? So the very first thing that you need to remember about this is this. If a is greater than 0, the graph opens up. If a is less than 0, the graph opens down. There is one more effect that a does have on the graph. Use our graphing program here. Y equals. So there's y equals x squared. Okay? Now, that's y equals x squared. What happens if I make it y equals 3x squared? What do you suppose is going to happen to this graph?
The slope will change.
The slope will change? Anybody else? Anybody else have anything to suggest?
It'll go wider.
Wider? Okay, good.
The
So-
lowest point on Y would be the 3.
The lowest point on the Y would be 3, so you think it's going to go up to 3? Okay. All valid. 1 close to right, 2 not right. Okay, but good guesses. All right, here's what I want you to do now. Let's just, before I graph it, I want you to think this through. So I did a table of values for y equals x squared, and I got this. Whoops, no I didn't. I need an eraser, so I'll go this, here. Complicated. 1, 0. Pardon me?
Wait, it says
Maybe up there. Oh, that's possible. Okay, so there's what I had for y equals x squared, right? Okay, so now let's look at it. We'll see. You're so smart. Yeah, brilliant. That's why we keep you around, doing. Okay, so now it's that, right? So now, let's put minus 2 in this equation. What is minus 2 squared? 4? 4 times 3 is? 12. Okay. Minus 1 squared is?
1.
1 times 3 is?
3.
0.
0. Still 0, okay. 1,
3.
3,
12.
12. So what's happened to my graph then? I said we were close. Marshall was close.
Same.
Marshall was close. What stayed the same?
All of it. Didn't it?
No? Marshall was close. He used the term slope, which is close. If I was talking about a linear equation, that's how I would describe it. I'm going to go back to what Casey said, because I'm going to actually use what he said and use that terminology, because that was closer to what I wanted as well. So if I combine the two, they got it right. Okay? It actually gets narrower. The graph goes up faster. It goes up steeper. Why? Because I'm taking this 3 value, and what am I doing to all my y values of my original? Timesing them by 3. By placing the 3 in front of the x squared, I take my original and I times all those values by 3. So how does it actually look then? Goes up steeper. Okay? So my graph goes up steeper, all right? Narrower. That's how I want to describe it. So by placing the value in front, if it is a number larger than 1, the graph is going to actually go narrower. If the number is between 0 and 1, meaning a fraction, it's going to go wider. So what's an example of that? Well, what if I had that? Y equals a half x squared. What would I do to all my original y values then?
Fine by 2.
Times it by what?
0.5.
0.5. A half. So what would that become?
2.
That would become 2, a half, 0, a half, and 2, right? What about my vertex in all 3 cases? Does A affect the vertex in those? That's what Sophia said earlier. She implied that maybe it affects it. But does it actually affect it?
No.
No, it didn't, right? Because I'm timesing all the y values by 3. Well, what's the original vertex? 0 and 0, right? What was the y value? 0. When I times it by 3, what do I get? Still 0. When I times it by a half, what do I get? Still 0. So A does not affect the vertex. Okay? A just affects whether it opens up or down and how wide or narrow it opens. That's it. We okay so far? So those are 2 things that we really have to know today. for that. 7.2 goes into more of the terminology, talks about the axis of symmetry. What's the equation of the axis of symmetry of all three of these graphs?
The y-axis.
Yeah, what's the equation on the y-axis?
X equals 0.
X equals 0. Right? Okay, so I'm going to jump ahead here a little bit. Okay? I'm going to jump ahead. Let's see if I can do this. That's clearing. Beautiful. Beautiful. Okay? So now what I'm going to do is, I said that the general solution or the general equation, all right, was y equals ax squared. So let's go y equals x shift squared. Now I'm going to change the b value. So I'm going to put it as x and I'll add 2. So I've got this so far. So this is y equals, I'll write it down so it looks better for you. This graph here, y equals x squared plus x plus 2. Okay, so there's the equation for this graph here. All right? I'm going to graph it, and then I'm going to adjust the b value. Right now, what is the a value in this equation? The a value is 1? What's the b value? Also 1. What is the c value? 2. Okay. What is the y-intercept of this graph? Where does it cross the y-axis? At 2. What is the x value at the y-intercept?
0.
Yes. Where does it cross the y-axis? Right there. Right? What's the x value along this axis? 0. If I put 0 in the equation for x, 0 squared plus 0, 0, 0 plus 2 gives me 2. So you see how that works? All right? Okay. Now, let's adjust this value now. And I want you to tell me, what do you think is going to happen now if I make it 3x plus 2? What do you think is going to happen to the graph?
It's going to be narrower.
You think it's going to be narrower? Well, what did we just establish, though? What affects how wide or narrow it
The
is?
a value, not the b value.
The a value, not the b value. So what do you think the b value is going to do?
It's going to change the height, maybe.
Height?
I'm just
Okay.
I'm just
That's a
guessing.
good guess. All right. You're actually not far off. Okay, that's not a bad guess.
Go deeper,
So
like have the same y-intercept, but go farther down.
lower? So what's going to change then? What's that one point that we have to remember about these graphs?
Symmetry.
The vertex. That's right.
Yeah.
Okay, the vertex. So what's going to happen to the vertex? What do you think? You think it's going to go lower?
I think it's gonna change, I don't know.
Change. Okay, whether it goes up or down? Sure.
Yeah.
Okay, so you both saying up or down now?
Yeah.
Anybody else want to guess something?
Side to side.
Maybe. Also could be left or right. We don't know.
Good.
Okay,
Thank you.
so let's have a look.
If it moved left to right, wouldn't that affect the steepness of it?
Well, let's find out.
Because it won't change, it shouldn't change the y-intercept. because it's two is still the same.
It shouldn't change the, what's right?
The y-intercept.
The y-intercept?
Not changing C.
Okay. So you're thinking, all right, so I like this. This is a good conversation here. So you're saying then that this value here isn't going to change.
Yeah, and I don't think it'll move left to right because that means the steepness will change.
The steepness will change.
The
Steepness would also change if you moved it up or down.
But you're all assuming that that has to stay there.
Yeah,
Does it have to stay there?
I think so.
According
It's not because you're
according to the math, yeah, it does.
Why? What math are you talking about?
Well, if you put them all in for 0,
You put 0 in for the axis?
yeah,
You're still going to get 2.
you still.
So you're right. You're absolutely right. Okay, so let's find out what is actually going to change then.
We're probably all wrong.
Okay. So by adjusting, so what did
Is
I?
someone right? Is
It's
someone
gonna
right?
go upside
Yeah.
down.
Okay. Okay. Well, it can't go upside down, right?
Negative.
Because the a value has to change. So what has happened here?
It did both. It went down and left.
I
said bold black
But
second.
the crossing point is still.
The y-axis is still the same as.
Interesting.
as the-
Which
as
is
arrow.
what I said, it stays the same.
Wait, hold on, just say this.
I didn't say it was right. I don't.
I
Okay,
said bold black second.
alright, so let's figure this out then. By adjusting my B value, what did I change, what happened?
The whole thing moved.
Your vertex.
My vertex moved quite drastically, correct?
Very drastically.
Right? So it moved down and also moved left by the looks of it. Right? Okay, well let's try one more then. Let's do it like this. Let's go y is equal to x squared minus 3x add 2. Okay? So now, what are we thinking?
It's gonna flip. It's going to.
Not gonna flip because that 8 is still, remember, the only
Yeah.
thing it affects the flip is the A value, right?
Instead of moving down, it'll move up and to the right.
Up and to the right,
Instead
okay?
of down and to the left.
Okay, well, let's check this.
Yeah, maybe.
Yeah, maybe? That's very
It moves to the
bold
right.
Yeah.
Hey, okay, got to this.
I would say right.
Okay, so now, which way did it move?
To
To the right.
Right, so that value changing there.
That value changes the side. Wait,
It changed it,
Changes the vertex.
the vertex, from moving left, right, up, down, okay? So, you guys are getting the gist of what's happening here. By adjusting them, you guys are doing some good thinking as to what are the options, what can happen here. But we aren't going to do it as much working with the B value, okay? Because we're gonna actually get it into a form, and that's our goal, is we're gonna get it into a form that allows us to predict exactly what's going to happen. So let me show you what I mean by that. I'm just gonna clear this all off now. Right, clear my graphs. So I'll show you where we're gonna end up here. Okay, so I'll start with the y equals x squared graph again. Y equals x. So there's my y equals x squared graph. All right, now it's difficult for us in general form. I think that's the term they use, is it general? Standard, sorry, the standard form. Okay, I'm gonna put it into what we call general form now. All right, general form works like this. I'm going to, and we will be able to arrange it so it always goes into this form to make it easier for us. But here's actually what happens. My general form for this is that. My general form is y equals a x minus h squared plus k. All right. So what does this all mean to us? Well, a is still a. It tells us whether it opens up or down and how wide or narrow it opens. So that's what a does. So what are h and k and what do they tell us? H and k tell us which way my vertex is going to move. H and k is my vertex. So depending on what I put in here for values for h and k, that is going to be my vertex. So an example of a graph would be y is equal to, not going to change a, minus 2 squared minus 3. So the width is going to stay the same. Because I didn't change my a value, it's still 1. All right? But what is going to change is where my vertex is. So my vertex right now is at 0 and 0. Right? I'm going to move it h units to the right and k units up or down. So if it's a subtract inside the brackets, I move it 2 to the right. So it goes to here. And on the outside, if it's a negative, I move it down. So it's kind of the opposite between the two, and we'll get that under control in a bit. So now I'm going to move my vertex 2 to the right and 3 down. So it goes to right there. Now, not only am I going to move my vertex there, I'm going to move every coordinate to the right 2 and 3 down. Here's my next coordinate at 1 and 1. Move it 2 to the right and 3 down, right there. this guy. 2 to the right and 3 down. Right there. My next one is, should be at 4. Oh, it's way up here. Okay? My next coordinate is there. So I'm going to move it 2 to the right and 3 down, which would be 2, 4, and 1. There we go. And then this guy's going to go 2 to the right and then 3 down. So it'll go right there. And my new graph, whoops, should have gone through there, will look something like that. So H and K. H moves left or right. And this is a little ways down the road here. K moves up or down. Okay? If it's subtract in the brackets, that means that that's a positive number. You move it to the right. If it's an, bless you. If it's an add in the brackets, that means you subtract a negative number, which means it moves to the left. And then on the outside, it's just as is. If it's a negative, moves down. If it's positive, moves up. Fair enough? Okay, so let's take a look. I'm going to delete this, all this ink. Everybody's okay? Clear ink. And I'm going to put that in. We'll come back to this. We're going to do this another day. I just wanted to start with this. So now my graph is, when I say it was a bracket, x minus 2,
Squared plus 3.
this
No, minus 3.
squared minus 3.
Oh.
No, not plus 3.
Okay, yeah.
Okay, so, and there it is. So it moved over exactly where I said. So if I look at all my coordinates that I have on here, they've all moved 2 to the right and 3 down from where they actually were to start with. Okay? Again, so looking at this now, let's go back to what we do need to know for today. What is the value of my vertex? My vertex then is 2 and negative 3. Perfect. What is the equation of the axis of symmetry? Very good. This is the line that divides it into 2 equal parts right there, right? So it's always the x value of the vertex, so the equation is x equals 2. Is it a maximum or minimum value?
Minimum.
It's a minimum value. Perfect. And what is the range of this graph then? Where's my lowest value? Negative 3. What's my highest value? So my range would be minus 3 to infinity. Right? What's my domain for this graph? For me?
Negative infinity, positive infinity.
Yeah, it is always going to be that. X and L of all risks. Okay, and that's what you need to know for today. All right. Any questions about that? Again, this will likely be another section in which we're going to use the graphing calculators in the iPads. We're going to need them. Yes, sir.
So the lowest value is always first, and then it's the highest value?
Yes.
Okay, so you begin the range in the middle.
Yes, it's always, the way I say it, the way I look at it, bottom to top.
Okay.
Left to right is the domain. So you always find that value that's the furthest left, the furthest right, and that's your domain. Range is bottom to top. Okay? Now, we got this.